Welcome to the deep dive. Today we're digging way past the usual dinosaurs.
Yeah, forget T-Rex for a minute.
We're looking at creatures that were maybe even more, striking before, during, and after the dinos.
Exactly. We've pulled info from some great sources like a deep dive video from Reuniverse exploring these lesser-known giants and oddities of prehistory.
It's like you think you know prehistoric monsters, but then you find out about some of these guys.
Some truly bizarre and amazing adaptations.
So our mission today: uncover these hidden gems. We're talking like a predator with no teeth but an insane bite. A bird with wings nearly the size of an F-16's.
Incredible.
And this mammal, get this, body of a bull, head of a boar. Sounds mythical.
It really does. So yeah, prepare to have your view of ancient life maybe expanded quite a bit.
Let's do it. Where should we start? Ancient oceans.
It's plunge right in. How about the Devonian seas? This is way back, like 100 billion years before the dinosaurs.
Okay, way back.
And the big player there, Dunkleosteus.
Dunkleosteus. Okay, sounds intimidating already. So this was a fish.
A huge one. A pelagic fish living out in the open water, big fins, powerful tail, built for the midwater.
Right. And the jaws. I read something amazing about its jaws. No teeth.
That's the incredible part. No actual teeth. Instead, it had these sharp, bony plates along the jaw edges.
Bony plates? How did that work?
Well, they think as it closed its mouth, these bony edges would grind against each other, like self-sharpening bone blades.
Whoa, nature's own knife sharpener. That's efficient.
Incredibly efficient. And deadly.
Okay, so how deadly are we talking? The bite force must have been immense.
Oh, absolutely staggering. Estimates put it around 4,400 newtons at the sides, but get this, over 5,300 newtons at the front, those bony points.
5,300 newtons. What's that compared to, say, something we know today?
Okay, think about a polar bear. Pretty powerful bite, right?
Yeah, definitely.
A polar bear clocks in around 2,570 newtons. Dunkleosteus was packing more than double that power.
Double a polar bear. Without teeth, that's insane. It must have been crushing shells and everything.
Exactly. Ammonites, early sharks, other armored fish, the placoderms. It wasn't just biting, it was shattering. It was the undisputed apex predator.
And how big did this thing get?
Pretty massive. Potentially up to 10 meters long, that's over 32 feet.
10 meters?
And weighing maybe 3 or 4 tons. A real sea monster.
And fast, too.
Reasonably, yeah. Estimates are around 30, 40 kilometers per hour.
Yeah.
So picture this huge armored head coming at you at, 20, 25 miles per hour.
Yikes. Okay, top predator. But I heard there was maybe a darker side, like within its own species.
There's pretty strong evidence suggesting Dunkleosteus was cannibalistic.
Eating its own kind. Wow.
Yeah, which might actually explain something about its armor.
Oh, what's that?
Well, the hypothesis is that this intense competition, this cannibalism, drove the evolution of that incredibly thick armor on the head and the front part of the body.
Ah, okay. If your biggest threat is another Dunkleosteus aiming for your head.
You evolve a helmet. Makes sense, right? Especially since the back half of the fish was relatively unarmored.
So attacks were probably head-on, targeting the most vital but also most protected area, a sort of evolutionary arms race within the species itself.
Precisely. But like all dominant species, its reign eventually ended.
Right, the Devonian period ended with some big extinction events, didn't it? The Quassa and Hangenberg events.
Exactly. Huge environmental changes. And Dunkleosteus disappeared along with many other marine species.
Why, though? What caused those extinctions? Still debated.
Very much so. There are the dramatic theories, a supernova, maybe an asteroid impact.
Wow, okay.
But also more Earth-based explanations, possibly linked to the rise of land plants.
Plants. How would land plants affect ocean giants?
Well, as forests spread, they change soils, increasing runoff of organic material into the oceans. All that decaying stuff could have sucked the oxygen out of the water.
Oh, low oxygen levels.
Yeah.
Anoxia.
Yep. And big active predators like Dunkleosteus need a lot of oxygen. So if oxygen levels plummeted.
That could have been devastating. Not just for them, but for their prey, too.
Exactly. Add in maybe changing ocean currents, potential release of toxic gases like hydrogen sulfide from the depths. It was likely a combination of factors. A perfect storm, really.
A sobering reminder that even the toughest apex predators aren't immune to global change. Okay, so from the mighty Dunkleosteus to something quite different. Arcturus.
Very different. Still Devonian, but much earlier. And this was a jawless fish.
Jawless. And the shape was weird, right? Like a spear and shield.
That's exactly what its name means. It had this really odd body plan. Small, though maybe only 15 centimeters, 6 inches long.
Tiny compared to Dunkleosteus. So what did it look like exactly?
Okay, picture a flattened top, sort of like a tortoise shell.
Yeah.
Flat belly, long flat tail with spines.
Right.
But the strangest parts were these two long, bony spikes or protrusions sticking out from the sides, almost roundish.
Spikes on the side, what were they for? Any ideas?
That's the big mystery with Duraspis. Theories range from helping it float, maybe balance.
Or telling each other apart. Species recognition.
That's another possibility. Or maybe even digging in the mud. But honestly, we don't really know. Their shape doesn't seem perfect for any one of those things.
What's the main problem in figuring it out?
We just lack information about how it lived. Was it on the bottom? Swimming it up on the water? What did it eat? Without that context, interpreting those weird protrusions is really difficult.
It's amazing how much we can figure out, but also how much remains a puzzle. And wasn't there another spike? Like under its mouth?
Yes, a central spike, a rostrum. Its position is odd, right under the mouth opening.
So what's the guess there?
Well, one speculative idea is that maybe it used that rostrum to stir up the sediment on the bottom.
To kick up little food particles.
Potentially. If it was a bottom dweller, that could have been an efficient way to feed. But again, that depends on where it lived. If it was pelagic, out in the open water, that theory doesn't work.
Right. So Duraspis is kind of an enigma. Fascinating because we know so little.
Exactly. A little armored mystery from the Devonian. It reminds us that the fossil record gives us glimpses, but not always the full picture.
Absolutely. Okay, let's jump forward in time quite a bit to two reptiles often confused because of their names, Mosasaurus and Mesosaurus.
Yes, sounds similar, but very different creatures, different times. Let's start with Mosasaurus, late Cretaceous. So this is during the end of the age of dinosaurs.
And Mosasaurus was the big one, right? The giant marine reptile you see in movies sometimes.
No, huge. Could exceed 10 meters, maybe weigh up to 70 tons.
70 tons, like a whale.
Pretty much. And interestingly, evidence suggests they were warm-blooded, gave birth to live young viviparous, and had high metabolisms, active predators.
Wow, so not your typical sluggish reptile image. What did they eat?
Pretty much anything they could catch. Fish, cephalopods like squid, sharks, other marine reptiles, especially sea turtles seem to have been a favorite.
So they were the top predators of their time, taking over from others.
Absolutely. They outcompeted the big sharks and the last of the pliosaurs to become the dominant marine predators toward the very end of the Cretaceous.
Until the big extinction event 66 million years ago.
Exactly. They vanished along with the non-avian dinosaurs. But their story is also interesting because they evolved from land animals.
Yeah, that's fascinating, seeing how they adapted back to the water.
It's a great case study in evolution. We can see the steps, the changes in their limbs, tails, bodies, as they became fully aquatic over millions of years.
Incredible adaptation. Okay, now let's rewind way back again for Mesosaurus.
Way back. Early Permian, so this is before the dinosaurs even existed, around 290 million years ago.
And much smaller.
Oh yeah, only about a meter long, maybe 3 feet or so. A freshwater reptile.
Freshwater, okay. What did it eat?
Little things, small crustaceans, tiny fish. Nothing too dramatic.
So why is Mesosaurus important then? It doesn't sound like a fearsome predator or anything.
It's hugely important, but for a completely different reason. It was key evidence for the theory of plate tectonics, continental drift.
Ah, right, because of where its fossils are found.
Exactly. Fossils of Mesosaurus are found in very specific rock layers in only 2 places on Earth, Southern Africa and Eastern South America.
And the key is, it was a freshwater animal.
Precisely. It could not have survived crossing the saltwater Atlantic Ocean. So, finding identical freshwater fossils on continents now separated by thousands of miles of ocean was a major puzzle.
Until Alfred Wegener came along.
Until Wegener. He looked at Mesosaurus distribution, the way the continents seemed to fit together like puzzle pieces, similar rock formations, other fossils.
And proposed that the continents were once joined in a supercontinent.
Pangaea, yes. His idea of continental drift, proposed back in 1912, was pretty radical at the time.
What the heck?
But evidence like Mesosaurus fossils was crucial support. It eventually led to our modern understanding of plate tectonics. So this little freshwater reptile played a huge role in revolutionizing geology.
Amazing. A small fossil with a massive impact on science. Okay, we've done oceans, we've done geology. Let's move into the era after the dinosaurs. Land and air.
Sounds good. Let's talk birds. Big birds. First up, the Paraceratherium, or as they're better known.
Terror birds, great name.
Isn't it? These were giant flightless birds that popped up after the dinosaurs checked out in the Paleogene.
Flightless giants. Where did they live mostly?
Primarily South America. It was an island continent back then, isolated. And these birds dominated as predators there for millions of years, from about 62 million down to just over 2 million years ago.
Wow, a long range. How big are we talking?
Some species reached up to 2.5 meters tall, that's 8 feet.
Taller than me?
Yeah, and weighing around 150 kilos, maybe 330 pounds. Big birds.
And built like predators, I assume.
Definitely. Huge head, massive beak, flattened side to side with a big, sharp hook on the end.
Ouch.
And powerful legs with large claws. They were clearly built for running down and killing prey. They were the apex predators of isolated South America for a long time.
So what happened to them? 2 million years ago isn't that long ago, geologically speaking.
Things changed when North and South America connected. The Isthmus of Panama formed.
The Great American Interchange.
Exactly. Animals started moving between the continents. And the terror birds suddenly faced competition from mammals migrating south. Big cats, bears, canine relatives?
And they couldn't compete.
Apparently not. They gradually faded out. One species, Titanus, actually made it north into North America for a while, but it eventually went extinct too.
So why flightless? Was it an advantage for them?
It seems so, in their specific environment. Flight is really energetically costly.
Right, it takes a lot of muscle, a lot of energy.
And if you don't have major predators attacking from the air and your prey is all on the ground, maybe the benefits of flight just don't outweigh the costs anymore.
So evolution favored becoming better runners instead of flyers.
Seems like it.
Yeah.
Their wings became small, maybe used for balance or display, but not for flight. Their closest living relatives today are the Siriemas, much smaller birds in South America.
Fascinating evolutionary path. Okay, from flightless giants on land to a flying giant in the sky. Argentavis.
Argentavis magnificens. Yes, another South American bird from the Miocene epoch, so it overlapped time-wise with some of the later terror birds.
And this one definitely flew, and it was enormous.
Mind-bogglingly enormous. Twice the size of an Andean condor, which is the biggest flying bird today.
Okay, so wingspan?
About 7 meters, that's around 23 feet.
7 meters. You said earlier almost like an F-16.
Yeah, just about 3 meters less wingspan than an F-16 fighter jet. It's almost impossible to really picture.
Seriously, standing height. Weight?
Standing, maybe 1.8 meters, so around 6 feet tall. Weight, probably 70, 72 kilograms, so 150, 160 pounds.
So how did something that big fly? Could it flap those huge wings constantly?
Probably not. Studies of its skeleton suggest its pectoral muscles, the flight muscles, were relatively small for its size.
So more gliding.
Exactly, like a giant glider. It likely relied heavily on soaring, catching thermals, using wind currents to stay aloft with minimal effort. Flapping was probably mainly for takeoff and landing.
Energy efficient. That makes sense for such a huge animal, but takeoff must have been tricky.
Extremely tricky. It probably couldn't just flap into the air from flat ground. The wings would hit.
Right.
So maybe running downhill into the wind, or launching itself from a cliff or a high point.
Makes sense. And what did it eat? Was it hunting? Swooping down?
The thinking now is that it's primarily a scavenger.
A scavenger, like a giant vulture.
Pretty much. Its build doesn't really suggest active predation on large animals. It makes more sense that it soared over vast areas looking for carcasses, maybe even scavenging the kills left by terror birds on the ground.
Ah, a nice synergy there, perhaps. And being so big, it probably didn't have much competition at a carcass.
Likely not. And studies suggest its daily food requirement was surprisingly low for its size, maybe 2.5 to 5 kilos of meat. That fits the scavenger lifestyle efficient flight, finding occasional large meals.
And this points to a certain life strategy.
Yeah, what biologists call a K strategy. Long lifespan, slow reproduction, maybe only 1 or 2 eggs every couple of years. Stable populations, limited by food availability.
A successful giant scavenger. But it still went extinct eventually, by the Pliocene.
Yes, it did. Despite its impressive adaptations, it eventually disappeared. Environmental changes, shifts in prey availability, even the most successful creatures face limits.
Another reminder of the constant change in life's history.
All right.
Okay, let's shift to mammals that came after the reptile's long reign.
Platybelodon.
The shovel tusker.
Yes, the shovel-tusked gomphothere, an extinct relative of elephants.
Lived. Miocene, Pliocene, pretty widespread.
Very widespread. Africa, Eurasia, North America. It even got to South America during the Great Interchange.
And the defining feature is right there in the name, those tusks.
Yeah. It had 4 tusks, like many early elephant relatives. 2 upper ones, probably curved down like you'd expect. But the 2 lower tusks were the weird ones.
How so?
They were fused together at the base, flattened horizontally, really broad, and lacked enamel. They looked just like a shovel or a scoop sticking out from its lower jaw.
A built-in shovel. What on earth did it use that for?
Well, that's been debated quite a bit. Early ideas were maybe digging up roots,
Makes sense with the shovel.
or scooping soft water plants or algae from lakes. The wear patterns on some fossil tusks seem to fit with scraping abrasive stuff, maybe like muddy roots or sandy water plants.
So the picture was this sort of swamp-dwelling, plant-scooping elephant relative.
That was a popular image for a while.
Yeah.
But more recent research, looking closely at microwear on the tusks, has kind of shifted the thinking.
Oh, what's the newer idea?
The patterns seem more consistent with stripping bark or shearing branches off trees.
So less scooping, more cutting, or scraping against wood.
Exactly, suggesting it might have been more of a browser, eating tougher vegetation, at least as an adult. So the shovel might have functioned more like maybe giant secteurs or bark scrapers.
Huh. Science marches on. Updating the image of the shovel tusker. Okay, one last creature for today. Andrewsarchus.
Andrewsarchus mongoliensis, a fascinating and somewhat mysterious mammal from the Eocene of Central Asia.
Known primarily for just a skull, right?
Almost entirely, yes.
Yeah.
A huge skull found in Mongolia back in 1923 by that famous Roy Chapman Andrews expedition.
And initially, they thought it was related to something else. Those hell pigs.
Yeah, the entelodons. Based on the sheer size and some features of the skull, the first thought was it might be a giant entelodon. Those things often described as looking like, a mix between a pig and a bison, but predatory.
Sounds charming, but that was wrong.
It was quickly reevaluated. It was classified as a member of an extinct group called Misonicids, which were actually hoofed mammals, but adapted to a carnivorous diet. Sort of like predatory sheep or deer relatives in a very loose sense.
Yeah.
Weird group.
Hoofed carnivores. Okay, ancient mammals were strange. And Andrewsarchus, based on that skull, was potentially huge.
Potentially the largest terrestrial mammalian carnivore known, ever.
Wow. How big are we talking?
Based on skull proportions, estimates suggest a body length of maybe 3.8 to 4.5 meters, 12 to 13 feet, not counting the tail. A tail maybe 1.5 meters long. And weight, possibly over a ton, 2,200 pounds or more.
That's enormous. And the skull itself was big.
Huge, about 83 centimeters long, nearly 3 feet, over half a meter wide.
And the look, someone described it as werewolf-like.
Yeah, that description pops up sometimes in reconstruction.
Yeah.
A massive head, powerful jaws. It would have been an imposing predator.
But here's the catch, right? It's all based on one skull.
That is the massive caveat. Yeah. In the century since that skull was found, despite lots of searching in the area and other Eocene sites, no other definite Andrewsarchus bones have turned up.
No skeleton, no other skulls.
Nope. Which leads to questions. Was that skull typical? Was it an unusually large individual of something else? Is Andrewsarchus even a valid, distinct genus based just on that one piece?
So it's this tantalizing glimpse of a potentially record-breaking predator, but shrouded in uncertainty.
Exactly. A huge skull hinting at a giant beast. But without more fossils, its true nature remains speculative. It really highlights how patchy the fossil record can be.
It really does. What an incredible tour, though. From self-sharpening jaws in the Devonian seas to little reptiles holding the key to continental drift. Yeah. Giant flightless birds and even bigger flyers. And these bizarre mammals like the shovel tusker and the mystery of Andrewsarchus.
Just shows, doesn't it? The history of life is so much richer and stranger than just the dinosaurs we usually focus on.
Absolutely. These creatures were incredibly successful, perfectly adapted to their own worlds, however alien those worlds seem to us now.
And they offer such amazing insights into how evolution works, filling ecological niches in ways we might never have imagined.
It definitely makes you think. If life produced creatures this strange and diverse in the past, what kind of completely unexpected forms might evolve in the future, given enough time, changing environments?
Yeah. What evolutionary paths are being explored right now that we can't even see?
And flipping that around, imagine some future intelligence, millions of years from now, digging up remnants of our time. What bizarre creatures or technologies would they puzzle over?
Huh. That's a great thought. What would they make of, I don't know, a rubber duck or a smartphone?
Exactly. What strange fossils are we leaving behind? Definitely something to ponder.